joint probability of x and y divided by the marginal probability of, you can define it for the conditional probability of y between x, then it will be the joint probability of xy divided by the marginal probability of x. Then, so this is, then following this product rule, we can have the product rule. What is that? The joint probability of xy is the product of the conditional probability of x given y times the marginal probability of y. Also you can write the conditional probability of y given x times the marginal probability of y. Now, in chapter 4, when we developed the joint probability model or bivariate probability model, I mentioned that, or we discussed that probabilities are calculated by finding the all possible combinations of the random variables and individually calculating their probabilities. But here we will see by applying this formula, we can easily calculate the joint probability of the random variables. Similarly, the marginal PMF of a random variable x can be calculated from its conditional PMF multiplied by the marginal PMF of other random variable and doing it for all values of the random variable. So a similar equation exists for all values of y if the conditional PMF of x given y is multiplied with the marginal PMF of y and that is done for all values of y, then you will get the total PMF of x. The base theorem also exists. We will see the base theorem separately. And this one we will see also. The joint probability, joint PMF of x and y, if becomes the product of their marginal PMF, then we will say x and y are independent. So, seeing this case, I think you will understand that there is nothing. Only thing that we are doing here is what? We are replacing the event A by a random variable. Sometimes B is replaced, B is replaced by another random variable y. Definitely both the random variables can be defined in the sense of business. Or we can have an event here. Let's see what it is. Any questions here? Anybody has a question? Then we can finish this lesson. All about next classes. And this formula should be written at the back of the book. Just your job is to fit the problem to a particular formula and write one of the margin. Okay. Now, any questions? First, we want to see the conditional distribution when it is conditioned on an. We will consider a very simple example. Very simple example. Right? Nowadays, there is a very popular one. What is it? Median. So if you need to turn on a fan, go there and turn it. If you need to turn off a fan, go there and turn it on. So do it. As simple as this, right? Anyway, just joking. You see now? So now we are considering the probability distribution of a random variable. That is PMF. I will only consider the PMF, but CDF is also set. CDF can be notation as well, but it is in the book similar things. And we are considering the most simple example, role FAR 6-sided time. Sample space is 1 to 6, and the set of possible values if we have a random variable x there is 1 to 6. We will consider an event outcome is an even number. So what is the what are the possible values of in the set A? What? And probability of A is following this formula that we have written here. The PMF of X given A for any value, this should be A. I have two conditions here, right? Probability of A should be greater than 0 and X should be in A. If X is not in A, then the probability will be 0. So, in this case, normally, if we write the PMF of X, what is it? Unconditional PMF of X is 1/6 for X is equal to 1 to 6, right? And it is 0 otherwise. The conditional PMF of X will be PMF of X given A. What? Any volunteer?
1/3.
1/3. Any other one? Let's see. For X is values of 1, 2, 3, 4, 5, 6, PMF of X is what? 1/6 for all values. And A is set of even numbers in between 1 to 6. Then X intersection A, only 2, 4 and 6. 1 cannot be there, 3 cannot be there, and 5 cannot be there. What will be the probability? Probability will be 1/3, right? How this is known? Because this PMF of X given A, what we will do X will be PMF of X for unconditional divided by probability of A. But any value of X, the probability is what? 1/6. For example, for 2, 1/6 divided by probability of A is this. Now question is why the formula is there? Just I will show it for 1. Let us write this one. The conditional PMF of X given A is what? What we mean by this? We mean by this probability that X is equal to X, right? What is the PMF of X means? Right? So this also means X to the 2. What is the additional thing? Given that
A has happened.
already. So now we want to know the probability of X having a value small x, given that A has already. Then if we consider that this is the conditional probability of, and I guess you also can recall X is equal to X is also a like in a X and X, it is an also a so then we have two events here. Then we can write probability that X is equal to X and even A has occurred. Divided by what? And X is equal to X and A. The intersection is what? Only the elements that are in A. So here, actually this X is equal to X and it will be X as long as what? X is in A. If X is not in A,
Zero.
it will be none. This set will be none, so the probability will be zero. So that's why this is the formula, and we have this one in place, right? Yeah, right here. Any questions here? So the unconditional PMF of X is this one, and the conditional PMF of X is very simple. Now, if we condition on another event, as I already have written on the very first page, the conditional PMF of X given Y is the joint PMF of XY multiplied by the particular PMF of the other element, Y. On the other hand, the conditional PMF of Y given X. Why is this written in this way? It actually is the PMF of of x given y for the value x given y, right, is equal to what? Probability that
Of x given that
X
y
equals
is
to x
and y to the
right? We want to know the probability of x having a value small x, given that y already is set to y, right? And once again, you can write this what? This conditional probability is the joint probability. Divided by what?
probability that y
And the upper one is what? And the lower one is the marginal value of y. So this equation is like that. Very simple. The rule is very simple, right? But the power is let us consider one thing you understand, that to know the conditional probability, what should be available? This is the conditional distribution, right? The joint probability and the marginal probability of y should be available, right? Now, for this example, let us focus here, right here. The joint probability of x and y is like this. Point 4, point 3, point 2, point 1. Instead of writing I have written 4 by 10, 3 by 10, right? Now, can we calculate the conditional PMF of x given y? The conditional PMF of x given y will be what? We need to first fix what?
y.
Let's say y is 1. Then we will have the conditional PMF of x given y for the value x given y equal to what?
1.
Right? And this one will be what? This one will be
marginal PMF of y given if y equals to
this will be joint PMF of x y. Right? Joint PMF of x y. Now let me get a little correction. We can calculate this one for x is equal to 1, and also we can calculate this for x is equal to what?
2.
But y is
Same.
y will limit.
y limits. Then it will be joint probability of 1 1 divided by what?
1.
And the other one, the joint PMF of x and y for the value 2 1, and the marginal PMF of y for the value. And once this one is the case, then what we can do? We can write here for the value x given y equal to 1 in this way. So the conditional PMF is also a complete probability model, like the conditional probability. There will be a probability here, right? When x is equal to 1. There will be a probability here when x is equal to 2, and it is 0.
Other
Can we fill this up? The dots, the boxes, right? We have 2 boxes. We have 2 boxes. Can we fill up these boxes? And that will go from where? Already we have written the formula, right? The formula is on the left side. So for example, we already set what? Y is equal to 1. Y is fixed to 1. And here we have y1, here we have y1. Now x can have 1, 2. When x is equal to 1, then what is this? The joint probability of xy for the value 1, what is that? 4 by
10.
And the marginal PMF of y equal to 1 is
6 by 10.
we need to fill up this one, right? This row, it will be 6 by 10 and 4 by
10.
so when we will write 6 by 10, it will be what? 4 by 6? And this one will be x is equal to 2 by 10 divided by what?
2 by 6.
2 by 10 and will be. So we have 4 by 6 and right? Yes or no?
Yes.
So can we? This is the case, right? Now we can have this for y is equal to 1. We have the conditional behavior is what are the value? 4 by 6 and
2 by 6.
is it possible that we can fill up this column?
Yes, sir.
And the values are here. All the necessary values are here, right? Is it possible we can fill up this? Behavior of x given y. For the value x is equal to 1, y is equal to 1. Right? Yes or no?
Yes.
Here, x is equal to 1 and y is equal to 2. And this one actually is the joint probability of x and y for the value 1, 2. And the marginal probability of y for the value 2. Joint probability of x and y for the value 1 and 2 is what? 3 by 10. And marginal probability of y for the value 2 is?
4 by 10. 4 by 10.
So we get here 3 by 10 divided by 4 by 10, which is
3 by 4.
so the bottom of the next one is
1 by 4.
1 by 4.
you do not need to do anything, right? And if we go for this one,
4 by
this one you
7.
understand, this is x given y. This one,
2 by
Y
7. 3 by 7. 1 by 7.
can you do that?
Yes, sir.
Do it.
4 by 7.
I think now we can fill it up, right? This is primary school level things. Dividing 3 by 10 by 4 by 10. Dividing 1 by 10 by, right?
Y given x. Approximately
It doesn't exist in the book. It is like the joint probability. No, that's why the assumption is not. But for this one, middle one, the assumption of the column should be 1. Otherwise, it is not a or a condition. And it is there. The summation should be, otherwise it is not a right? We got it? We got it? Or not got it? So the first thing that we have to do is, right? Yeah? 4 by 10 will be divided by 7 by 10, so it will be 4 by 7 and 3 by 7. And then this will be 2 by 3 divided by
1 by 3.
when x is equal to 1, then y equal to 1 occur with probability 4 by 7 and y equal to 2 occurs with probability 3 by 7. Now, in this case, the row sum should be. We understand it? Very simple. Now the product rule. The product rule is as same as clear? Check. Just A is a random variable, B is a random variable. Same thing is there. Here it is the conditional probability of A given B, here the conditional behavior of X given Y. And instead of probability of B, we have marginal behavior of Y. Right? So you have a problem to solve. We have a professor. The specialty of the professor is has her facts wrong. That means she answers each of her students' questions incorrectly with probability. That's what her name is.
Maybe.
Now what happens? And since she actually answered or incorrectly answered questions, that's why she does not allow too many questions. She either allow only 0 question or 1 question, and that was. So in some lecture, does not allow any question. In some lectures, only 1, some cases only 2. And each of these occurs with is the problem scenario clear? Now let us assume that X is the number of questions professor may ask. And Y is number of questions here answers wrong. So X is the number of questions, Y is the what is your job? Finding joint BMF of X and good. This question was sitting in an exam. There are challenges here, first challenge. You need to identify from the random variable that are defined in the problem. Right? Whether you follow the first one or the second one. Based on what? Whether the marginal BMF of X is available or the marginal BMF of right? And if the marginal BMF of Y is available, then you are in the first problem. If the marginal BMF of Y is available, then conditional BMF of X is available as well. And more specifically, you can consider among between X and Y, which one is independent variable. This independent is not the independence of X and Y. This is between two variables, one is the independent one, another one is dependent on. For example, when we draw this graph, then which one is independent and which one is dependent?
Generally, X is independent.
Generally, all the times. X is the independent variable. For each value of X, you can have a value of Y, right? So you need to identify which random variable is the independent random variable and which random variable is the dependent. So once again, let's get back here. Among these two random variables, which one is independent? X or
Where X is the independent variable.
so we'll calculate the marginal BMF of X, right? Is the marginal BMF of X available? Yes.
Yes.
1/3.
It is 1/3 for X is equal to 0, 1 and
2.
0.
Otherwise,
Now, for each value of X, we will have a set of value of Y. For example, where Professor A is asked 2 questions, how many wrong answers could be there?
0, 1, 2.
So the possibilities are 0, 1 and 2. If Professor May is asked 1 question, well, if X is 2, then Y could be 0, 1 and 2. If X is 1, then Y could be
0, 1, 2.
And X is 0. If no question is asked, there is no chance of giving wrong answer, right? Now, from here, one thing that we need to identify, given Y, given, so X, what is the distribution of Y? That means usually we use this, right? X is uniform, Pascal, binomial, Bernoulli, Poisson. We also can write this. The distribution of Y, given that X has a value, so like that, the conditional distribution of Y is what? Now, do you know what is the distribution of Y? If 0 question is asked, 0 wrong answer. 1 question is asked, 0 and 1. This would be part of it. Bernoulli related variable is a special case of binomial. Yes or no? When it is equal to 1 in case of binomial, then this becomes. And when two questions are asked, 0, 1, number of successes. So it will be a binomial random variable. What are the parameters?
N,
Okay, what is the value of n?
X. How many trials?
Who said x? You? Who said 6? And what is the value of p?
1 by 2.
Right? So the conditional PMF of y is a binomial random variable with parameter x and 1. So if we write the PMF here, it will be what? Given x, it will be y successes, right? And 4 to the power y, 3 over 4 to the power,
X minus
X
y.
minus 1.
and y is equal to, what is the range for y? X is fixed, but x also has a range, 0, 1 and 2. But what is the range for y?
So considering y is less or equal to x.
0 to x.
When x is 0, it is 0. When x is 1, it is 0 and 1. It is 0, 1. So can we then, oh, it was here. So x is uniform, right? With values 0, 1 and 2. And PMF of x is 1 over 3. Or given x is binomial with parameter 1 over 4. And the distribution is x choose y, 1 over 4 to the power y, 3 over 4 to the power x minus y. X goes from 0, 1 to 2, and y goes from 0 to x. Now, fill up this.
Sir, before uniform set we use x is uniform.
Do you understand? Equal probability. Numbers are 0, 1 and 2 is proportional.
Each event has equally likely.
Equally likely and so the uniform distribution. So fill up this. Shall we do that? When x is equal to 0, y, sorry, x is equal to 0, what are the possible values of y?
0.
And what is the probability?
1.
Very good. When x is equal to 1, we can use this, right? This formula is right here.
Half of
Oh, not half. When x is equal to 1, y is 1. 0 or
0.
right? So when x is equal to 0 and y is equal to 0, what is the probability?
3 by 4.
Put it here. When x is 0, y is 0. 0 so 0 is 1. Then 1, this is what? Y 0, it will be 1 over 4 to the power 0. And 3 by 4 to the power 1. So it will be 3 by 4. And when x is equal to 1, y is equal to 1 will be 1 choose 0, 1 choose 1, 1, then it is 1 over 4, right? Now when x is equal to 2, values are from here. This will be 2 choose y, 1 over 4 to the power y, and 3 over 4 to the power 2 minus y. When y equal to 0, then it will be what? 2 choose 0 is 1. Then it will be, when 0 it will be what? 9 by
9 by 16.
6. When y is equal to 1, this will be 2, this will be 1 over 4, this will be 3 over 4. So the number will be
6 by 16.
6 by 16. And this one will be
1 by 16.
right? And all others are,
0.
we can calculate the marginal PMF of x here. What is the marginal PMF?
okay.
Of x? No, marginal marginal PMF of x cannot be calculated from here. This is difficult. Now, how can we calculate the joint PMF of x? Joint PMF of x we can calculate from the conditional PMF of y times the marginal PMF of x. What is the marginal PMF of x?
1/3.
So what will be the joint PMF of x and y? 1/3, right? Then it will be 3/12, 1/12, then it will be 9/16, then it will be 9/16. Sorry, my mistake. 9/48, then it will be 6/48, then it will be 1/. Now, if you calculate the marginal PMF of x, you will find it is what? 1/. This one is 3/12, 1/12, 4/12 is what? This one is 9/14, 6/48, 1/48, and the 16/48 is. So, joint PMF of x and y has been calculated. We understand it or not? No? Yes or no? What is it? You can understand it. Let's solve the next one. Okay, before going to the next, what is the probability that Professor May will give at least one wrong answer? Tell me, what is the probability that in a class she will actually?
11/48.
So he is 11/48, 11/48. You? One third? One third?
11.
Easy way, easy way. So in this column, how many wrong answers?
0.
So we do not add up this. In many column, how many wrong answers?
1.
In many here?
2.
So at least one. So 1/12, 6/48, 1/. So not all problems are difficult. So here is the answer. Now, here is a question for you. By now, you should be able to solve it. What is it? It says the joint probability of two random variables is what? The product of the conditional PMF of one random variable with respect to the other condition of the other times the marginal PMF of the other and vice versa. You can also have this formula in place. As I mentioned earlier, which one will you use? First one? For this problem, x and y actually are not dependent on one another. Right? However, if we assume that x has a specific value, at that time y becomes dependent. So if you decide that x be on the x-axis, then x will be independent and y will be, and in that case we will be using this formula. If you assume that y is independent, then actually x will be on the along the x-axis, y will be along the x-axis, and it is independent. Right? Is this clear? Let's say, according to this solution, we assume that x is the independent random variable. If x is the independent random variable, what is the distribution of x? Who will please? X is binary. Because here 1 You roll a die 4 times and you are counting whether there is one or not. How many ones? Each one actually is considered as a success and you are counting the number of successes. So X is binary. What are the parameters? How many times you are tossing? Rolling? And what is the probability that you get a 1?
1 by 6.
1 by 6.
Thus, the behavior is yes. What is this?
Also by 2.
Hmm?
Also by 2.
Now we are counting the number of twos.
Number of 2 is
In how many tosses?
4 tosses.
4 minus 6.
4 minus 6. Like the number of ones you
Already number of ones should be excluded. If you got 1 times the number 1, then actually 2 are only for the remaining 3. Maybe may not. So this one is also what? What are the parameters?
4 minus x.
And
Not 4 minus x.
okay? Actually, it is not good. Why so? The remaining 4 minus x times, it is not possible that you will get a 1. Sorry, you will not get a 1. Whatever number of 1 you have got, you already got it here. X is actually,
So 1 by 5.
So 1 by 5.
so probability will be, is it acceptable?
Yes, sir.
And so the PMF is right? Here X can be from 0 to 4 and here Y can be from 0 to X. And then joint PMF is
Minus x minus y.
which formula we are using? This one. Then the what is the joint PMF? Joint PMF is here. The conditional PMF multiplied by the R. So I write it in a wrong way. So let us consider. The joint probability will be the conditional probability of Y given X times multiplied limit of X, and the conditional PMF is 4 minus X Y 1 by 5 Y 4 by 5 4 minus X minus Y, then 4 choose X 1 over 6 to the power X 5 over 6 to the power. Okay. So now there is another problem. I will quickly skip this one. That is very tight. Quickly skip one. It says X and Y are two independent binomial random variables. They are binomial random variable and they have same probability of success, but the other parameters are not same. That's why they are not identical, but they are independent. It is something like you are tossing n1 times, then take a pause, and again tossing n2 times. These are independent, but they have the same variability. You are using the same point to toss. Question is, calculate the conditional PMF of x1 given we are not considering one random variable given another. Whether one random variable given the sum of that random variable and other random variable to sum it. So we want to calculate that x1 is equal to a, given that x1 plus x2 is equal to a. If we assume that this one is given a and this one is given b, then we can write the probability of a given b is equal to the joint probability of A and B divided by the probability That's what it is written. A is x1 equal to k and B is x1 plus x2 equal to m. So just applying the condition of probability, you get this line. So this line to this line is very simple. Why? Since x1 is equal to k, what we do here? x2 is equal to m minus x1. And x1, since x1 is equal to k, we can replace x1 by k. So that's why we are here. x1 is equal to k, x2 is equal to m minus k. And also we can write, since this x1 and x2 are independent random variable, we can also write this. Why? If the probabilities are independent, the events are independent, their joint probability is equal to product of their individual probability. Right? And here, now this one is what? X1 is binomial, right? It is given. X1 is with parameter what? M and B. So can we write the probability x1 for the value k? Can you write it? What is it? N1 choose k, k to the power k, q to the power n minus k. Q is equal to what? 1 minus p. And what is the distribution of x2? Sorry, this is x2. x2 is also binomial. So we can write this one here. Just n2 choose m minus k. Since m minus k is here. And now if x1 is binomial and x2 is binomial, their sum is also binomial. So it follows this. So we can calculate the probability that x1 is equal to k and x1 plus x2 is equal to a is equal to. Is it familiar? It is the hypothesis. Previously we did not have a derivation, now the sum rule. What does the sum rule say? The marginal PMF of x can be calculated from the condition of PMF of x multiplied by the marginal PMF of y for all values of if the conditional PMF of x is given and the marginal PMF of y is given, can we calculate this? Do it. And the formula is, what is the formula? So whatever will be here is here. What will be the value here? Any volunteer? We have already seen PMF of x is what the value 1 is. What is the PMF? PMF of x. What is the PMF of x? 7 by 10. And now if can we get that 7 by 10 from here? How? This one multiplied by this one plus this one multiplied by this one. Right? The marginal condition. Actually, a bar is here. Right? A bar is there. A bar is there. So, let me write it. This quantity is what? PMF of A is for the value 1. Now it is application of this. We start with y is equal to 1. Then it will be, formula says, the conditional PMF of x given y for the value x is equal to 1, y is equal to 1, multiplied by PMF of y for the value plus PMF of x for the given y for the value x is equal to 1, but now y is equal to 2, marginal PMF of y for the value 2. Now, what is this value? What is this one? What is this one? What is this one?
7.
So what is this divided? Right? How it should be. But the calculation will also show. How? This is equal to this one multiplied by this one. Results in 2 by 10. This one multiplied by this one. Results in 1 by 10. 2 by 10 plus 1 by 10 equal to 3. Yeah. Right? Here is the formula. Any questions? Yeah. Conditional expectation. We know expectation, right? Expected value of x is what? For all values of x, x is multiplied by the PMF of, right? And the conditional expectation is, even you can have this one. X given y equal to y is what? X multiplied by x given y for the value x given. So both these two are applicable. Now for this one, it is, you just take, there are examples in the next exercise. Let us test this one. This is very important. This will reveal one of the most important topics of this chapter. So important that most of the cases one question is set. Not guaranteed, but most of the cases you will encounter one question and a very difficult one. Not like this one. Okay, what is this? Here actually the marginal PMF of, conditional PMF of x is given, right? And our objective is to calculate the conditional expectation of x. What is the formula? The conditional expectation of x, condition on y is equal to y will be for all values of x. What we need to do? X will be multiplied by what? Conditional PMF of, right? So, if we want to calculate this one, x given y equal to 1, right? We can calculate this one. Also, we can calculate good. X is equal to conditional expectation of x given y equal to 1. Conditional expectation of x given y equal to, can we do that? This is very simple. What it will be? This one is equal to 1 times 4 by 6 plus 2 times 3 by 4. 3 by 4? No, you are right. 1 times 4 by 6 plus 2 times 2 by 6 equal to what? 8 by 6. 8 by 6? I think you have a problem in evaluating this equation, right? This summation. This summation is like a loop for x is equal to 1 to 2. E of x given y equal to 1 plus equal to what?
X into
X times here x, here 1. Right? So when the loop goes from x is equal to 1 to 2, right? 0 is not there. So when x is equal to 1, we are here. So what is this part? 1 times, what is this probability? 4 by 6. Then we go to the next part. When x is equal to, give me go. When x 4 by 6. Plus when x is equal to 2, the probability is
টাকা কিনে দেবে
equal to what?
বেশ
8 by 6, right?
5 মিনিট বসে
And this one is when y is equal to 2, we are here. 1.3 by 4 plus 2 times 1 by 4 equal to what?
5/4.
You got this? Now, if we want to calculate the expected value of x, what will happen? We have not calculated it. What is the expected value of x? Anyone tell? 1 times 7 by 10, right?
Plus 2 times 3.
This is equal to what? Is this clear? Now, the most important topic of this is this quantity expected value of the random variable is a constant. We have been telling this one right since the beginning of chapter 2. Is it okay or not? The expected value of a random variable is a constant. The conditional expectation of a random variable is also constant.
Yes.
This one, is it constant?
Yes.
Is it constant? No.
No.
As y changes, when y equal to 1, this quantity is what?
Change it.
When y is equal to 2, this quantity is? Can we say this quantity actually is a function of what?
Why?
When y equal to 1, this is 8 by 6. When y equal to 2, this is?
5.
And y itself is what? Y is what? Y is a random variable with PMF what? What is the PMF of y? 6 by 10 divided by 4 by 10, right? 6 by 10 divided by 4 by 10. Now, if this quantity is a function of random variable y, then we already declared that the function of a random variable is a function of a random variable is also random. Is this clear? If x is a random variable, y is a function of x, we told that such a random variable is defined as derived random variable. We discussed that. Derived random variable. So, this expectation somehow now becomes what? Let's say this is z. Then z is a random variable. So, what is the PMF of z? Any volunteer here? PMF of z is when y is equal to 1, z has this value. Y is equal to 1 occurs with probability 6 by 10. With probability 6 by 10, z has a value 8 by 6. And with probability 4 by 10, z has a value what? It is 0. If now z is a random variable, z also has an expected value, right? What is that? Its value multiplied by probability plus its value multiplied by which actually is problem now becomes
1 থেকে বড়
this quantity and this quantity So are Z and X identical?
ও না ঠিক আছে
Actually, what we are telling that say, is it actually X or it's a coincidence? Is the question clear? What are the possible values of Z? 8 by 6 and 5 by 4. And probabilities are 6 by 10 and 4 by 10.
এই
You
ভাগ দিয়ে
agree
বের
with
করছে
the PMF of Z or
ভাগ
not?
করে বের করছে একশো কত
It is coming from here, all along. Right? It's coming from here. So now what we reveal that? What? What we reveal that this Z actually is not a pure random variable, it is X. And if it is X, then we can say the expected value of X actually is found by what? Just focus here. Multiplying the expected value of X condition and Y is equal to 1 by the PMF of Y for the value 1 plus
তোর জন্য $2
expected value. Sorry.
তোর জন্য $2
Expected value of X given Y equal to 2 multiplied by the PMF of Y for the value. Right? We did this one exactly. This one is what? For all values of Y, we are actually conditional expectation of Y is multiplied with the PMF of Y. Then actually we get the expected value of X. So here what we are doing, we are calculating the expected value of X part by part. For each value of Y, we are calculating one expected value. For another value of Y, we are calculating the another expected value. And the weighted average of these two actually giving us the total expectation of X. That's why we call this formula. Is it written here? Law of total expectation. This law of total expectation is a very powerful formula. Very powerful formula in the sense it gives you the ability to calculate the expected value of a random variable without knowing the without knowing the probability model, you can calculate the expected value. We'll see the major example in the next class. But for now, we'll finish this class with this example. Very simple one. A person Sam, taken from the book of Ross, will read either one chapter of his probability book or one chapter of the history book. A student who is taking the course probability will. Now, if the number of missprints in a chapter of the probability is portion distributed with mean. Probability book, number of missprints in a chapter is portion distributed with mean. And the number of missprints in the history chapter is portion distributed with mean. Now, assuming that Sam is equally likely to choose either of them, what is the expected number of missprints he or she will come across? What is given here? It is given here the X. X is what? Number of missprints. In a chapter. Right? Irrespective of the book. Then X and what is Y? Y is a variable, we call it indicator random variable. Let's call it indicator random variable. It is 1 when Sam reads the probability book and it is 0 when Sam read it. Then x given y equal to 1. What is the distribution? Is it available here? Yes, sir. The number of discrete x, that means number of discrete which is x, is Poisson distributed with mean. That means this distribution is Poisson with
Two.
Then lambda equal to
2.
and x given y equal to 2 is what? Once again Poisson with parameter. Right? Now, what is the PMF of y available? Anybody? Right? Half of the cases we will read the probability, half of the cases. Now, the expected value of x following that formula is what? Expected value of x given y equal to 1, this is check. Times PMF of y for the value 1 plus expected value of x given y equal to 0 times PMF of y for the value 0. We have the values. This one is what? Expected value of, what is the expected value? 2. Probability is half. Expected value 5. Probability is, what is it? So, you have the class after this?
Yes, sir.
Really?
Yes, sir.
Sir, could you put one slide before? A bit back, the last.
How far?
I think a bit ago.
What is the topic?
Just two slides before.
No. You started with one slide. I already covered 3 4 slides. So you need to take the topic.
The topic was sum of total probability.
2. I already passed 2. Now how many?
Yes, this one.
Okay.
And the slide after that. So this is before, I mean after.